I don't know how many of you have seen the movie Nacho Libre. I made it through about 30 minutes of it and flipped it off. It felt too much like Napoleon Dynamite to me. I'm like, this is just stupid. But there's a guy at my church who loves it. I don't get it. And every time he comes up to me, he's like, I want to talk about the nitty gritty. So anyway, there's apparently a line in that movie where he says that, so I threw it up there. The nitty gritty configuration of a VPC environment. Our mission as we go into this nugget is to walk through a manual configuration of VPC, which I believe will expose to you, that's how it all works and fits together. Here's your do I know this already? So take a look at the 3 questions and see if you do. If you do, you can move right along to the next nugget. Otherwise, let's get started. Well, this will likely be the only slide because we're going to be in the live configuration for just about the entire nugget. So Jack Black may have to go as we use the whiteboard space. But here's my goal. My goal in this nitty-gritty configuration is to manually configure a VPC environment with 2 separate subnets, launch a couple EC2 instances. We'll just use some Ubuntu instances for the ease. Set up the relationship between them, both in a routing perspective, internet access perspective, and even security perspective. Although I'm planning to have a complete nugget dedicated to the VPC security, you'll get a taste of it in here, right? So hopping into the AWS Management Console. Hopping to a lot of hopping VPC. You can see I'm in the North Virginia region and there is nothing here. Now we are not going to touch that wizard. I'm going to go straight to your VPC, which I call the master subnet of the VPC cloud. We'll name this Virginia. Well, let's just call it Virginia Core Subnet. All right, 172.30.0.0. That's actually what I use for my house. I have subnets at my house, public wireless access. It's awesome. You gotta come to my house. So 172.30.0.0/16 will be the master subnet. We'll use default tenancy, so we are sharing our machines with other customers of Amazon, and that's okay. We don't want to pay for dedicated devices. So there's the Virginia Core subnet. Then I'm going to go and create my subnets of the subnet. So create the subnet. Let's do subnet 1. And I copied it to my clipboard already. 172.31.0/24. VPC will be the Virginia Core. We'll throw it in East 1A. And there's my CIDR block. Right? So that's subnet 1. Normally you would probably name that web subnet or database subnet or whatever you're going to use each one of these subnets for, whatever your purpose is for the segmentation. So I'll do subnet 2. We'll do 172.30.2.0. And we'll throw that in there as the CIDR block. East 1A, just kidding, 2.0. All right, there we go. Amazon is awesome. Isn't it? I mean, they tune their system so well that it's like, oh, pop up. It's it's not one of those things where you submit. It's like, please correct this. It's just like it's just there. It's on top of it to guide you through it. Okay, so I've got the 2 subnets created. Now let's add in an internet gateway because these guys have to get to the internet. Check out how simple this is. What is the name of the internet gateway? Let's call it internet. Now you don't have to worry about this internet gateway being redundant or anything like that, or adding multiple internet gateways, because this is using Amazon's core routing infrastructure. If you have a single internet gateway, that's cool. You can point your subnets to it. Now let's talk about the routing tables. So right now let's just draw a quick diagram over here. We've got the Virginia region and the VPC we've called Virginia 172.30.0.0/16 as the master subnet. And inside of there we've created 2 subnets, subnet 1 and subnet 2, 172.30.1.0/24 and .2.0/24. Now we need to connect. Does this work? This is the first time in 10 years I've ever used the eraser on my pen at CBT Nuggets. That's awesome. So we're going to have the internet gateway, essentially the router off to the internet, that we're going to attach to these 2 different subnets. Now that's going to open the can of worms on the routing table, meaning I need these guys to get to the internet. However, just attaching them to an internet gateway doesn't do it. Let's go over there and I'll show you how this works. So I'm going to say I need to attach the internet to the VPC. Let's call it Virginia Core. See it? By the way, see how I did that? Internet attached to VPC. It's just kind of a lingering internet gateway, and it goes, okay, I'm attached. But right now, the subnets over here don't know how to get there. Notice I've got subnet 1 and subnet 2. If I look at the routing table, this guy says, hey, I know how to get to the master subnet, meaning these subnets know how to reach each other, and essentially any 172.30 subnet that I create. Now, again, keep in mind, reaching each other from a routing perspective, very different than reaching each other from a security perspective. So routing, Amazon does for you. They're like, why would you not want that? You want to have reachability, at least from routing, but you may want to put security in between these subnets so that they can't access each other from a firewall perspective, right? That's totally cool. So notice each of these guys has their own little route. I'm going to go into the subnets, click on Edit for subnet number 1. And I'm going to, oh, actually, that's not, I'm under the subnet. I need to be under the routing table. I'm going to go into the routing table for subnet number 1. And you can see I've got the routing table, the single routing table, which is actually associated as the main routing table of this. Click on Edit. And we'll say the default routing table for this entire VPC for 000/0, which is the default route, is going to point to that internet gateway that I just created. Now notice, it puts the little description in there. I named it internet. Thus, it's there. That's actually newer in the Amazon Web Services world. They didn't used to. It used to just have the code name, which was difficult. Okay, so I'm gonna click on Save. Now it says, okay, the default internet route is there. Now, when I look at the subnets, notice what's happening. Each of the subnets now have this internet table, or I should say this internet route. That means that any EC2 instances I launch into those subnets will automatically know how, from a routing perspective, to access the internet, right? So let's do that now. Let's get some real machines inside of there that are working. I'm going to go over to EC2, and I'm going to spin up 2 instances. So I'll click on Running Instance, Launch Instance, comes up with a wizard. Actually, just thought of something. Let me shoot back here. I'm going to go to the VPC and hit the security groups. Because otherwise, I just let it create a security group every single time I spin up a wizard, and I end up with a zillion of these little security groups that I have to come back and figure out what they go to later on. So I'm just going to create a security group for my normal Linux instances. So I will call this SSH and ping. How about we just generify that and say ICMP. So we'll just say allows SSH and ping access, right? This will be in my Virginia Core VPC security group, hit create. So that way I can assign that to every single instance I roll out there, and I don't have a zillion of these little security groups hanging out. Now, security is going to be a later nugget in this series, but for now, I'm just going to show you, click on inbound rules. I've got nothing. Click on edit. We'll say custom. Actually, we'll just use Amazon's real quick shortcut. We will allow SSH from anywhere, which, by the way, is not a good security practice. And we will allow, let's go ICMP from anywhere. Also, not a good security practice, but at the same time, great for a lab environment where you're testing things out. And actually, it is not uncommon to see this all the time in the quote-unquote real world. It's just, it's not good because you can have people hammering away at your SSH username and password time and time again without regard. So we got the security group created. Now let's head back over and launch the instances. So EC2, running instances. Click on Launch Instance, and we'll go with the Ubuntu side of things. Actually, I knew something looked funny. I've got my... You ever zoom your screen in accidentally doing this kind of thing? I do that all the time. There we go. Ubuntu, select. So I'm going to go with micro size instance. Next, we will say that this is just one instance. I'm going to say this will be in subnet number 1. Right? This will be the first VPC subnet that we're in there. We're going to let it keep everything else at default. And we'll go with next, add storage. Looks good. Next, we've got any tags, security group. That's what I wanted. So I'm going to click an existing group, and we'll go with the SSH and ICMP. Review and launch. Looks good. Launch. Yes, I have that key pair. So let's launch. While that one's kicking off, let's go in and shoot up one more instance in the other subnet. Now, question, can I go in there and actually just launch 2 instances at the same time? Sure, you can do anything. You can come up here and just say, I want 100 10 instances at the same time. But the problem is when you launch them into a subnet, Amazon's really picky. Let's just call it that. Picky about moving your EC2 instances between subnets. Is it possible? Like, oh man, I kicked off 2 instances and I put them in the same subnet. Can you move them? Yeah, you can. But here's how you do it. You actually go in and you delete the instance. Yep, you blow it away, but you keep the EBS hard drive. So you keep the hard. It's like you sever, parts from your instance, and you leave the hard drive of the instance hanging out there. Then you recreate the instance in the right subnet, and you reattach the hard drive to it. Sound like fun? Yeah. So that's why we want to create them in the right subnet to begin with. It is possible to move them, but you really don't want to. So I'm going to go to SSH ICMP. One of the fields. Hang on. Open the world. That's fine. One of the things I want to mention. You will get the feel after playing around with Amazon Web Services that Amazon means these machines for destruction. That doesn't sound good, right? But I was just talking about Chaos Monkey, right? When you get in there, like let's just say you mess something up and you lose access to your instance, like you mess up the networking. Can I go in there and kind of bail out? Amazon will say, no, just trash the instance and create another one. It's like, I mean, think about saying that to a typical IT guy. Oh yeah, no, just format your server, start over again, right? I mean, they're like, what are you talking about? Well, that's kind of the mindset Amazon has. Is there ways that you can kind of hack your way into an instance that you've lost the networking on? Yeah, you can, but usually it's like, you know what? It's so much work. Why would you? And Amazon's like, you know what? Why wouldn't you just write a script that's tried and true that spins these things up generically anyway? So anyway, just trying to get you inside the mind of Amazon. So we've got a couple running instances, looks like. And we got the right group, view rules, correct, ICMP everywhere. Good. Now, we just talked about ENIs, right? How do we get additional network interfaces on these guys, and to where we can actually get them as static addresses, a little more stable. You can see right here, they're coming from the right subnet, which is good. This guy's in subnet 2, this guy's in subnet 1. That's cool, but they're dynamic. I want to go in and I want to add an ENI that if this machine does get thrashed, I can rip the network interface off and I can put it on another machine. So I'm going to come over here to the network interfaces, right? And I can see right here are the 2 primary network interfaces of the machine that are listed under my network interfaces. I just clicked on the security group. So that's these 2 guys, right? But I'm going to create another ENI, a second network interface, and we'll call this guy subnet 1. All right. And we will say this guy is in the 172.30.1 subnet, private IP address 172.30.1.50. Check it out. I'm going private, right? Private IP, static IP address, create. Okay, so we've got subnet 1. There we go. I think this is from some older thing. Let me just see if I can delete that guy. There we go. So subnet 1. We'll then create another one. We will call this one subnet 2. Throw him in 172.30.2, 172.30.2.50, right? Just, again, picking a nice common static IP address that we can assign. Okay, good. Now, we have the instances, right? We have, and they are running. Looks like one's done. The other's probably on its final initialization. We've got the security groups assigned to them. Looking good. We've got the ENI, the Elastic Network Interfaces. What else are we missing? What else? Okay, so we need the Elastic IP addresses, right? Because these are all totally private. We do not have the ability to go public with them yet. Now, I'm gonna mention some. Well, I'll just mention it as I go. So right-click on this guy. I'm gonna attach the network interface. We're gonna say this is gonna be the subnet 1 interface. So attach that guy. Bam! Just like that. ETH1 shows up. You can verify the IP address right there. Isn't that awesome? While it's running, while it's all happening, I can attach the network interface. And we'll go subnet 2. Bam! Who is that guy? It just hit me. The Emerald Chef, throwing this. We're like the Emerald of AWS machines. So I'm going in here. Good, right? So everything should be good, right? Right. I'm giving you some hesitation here because doing things in AWS hardly ever takes into account the underlying machine. Here's what I mean. Ubuntu, right? Linux, very scripty, very text file modification-ish, very like you admin guy are involved. So even though we added ETH1 there, Ubuntu's not going to recognize that until you and I get involved. So what does that mean? That means that when I shoot over here, let's pop over to VPC, and I assign a public IP address, which is done under the elastic IP addresses. Hey, cool. We've got 2 of them allocated already. We could grab another address if we wanted to and toss it in there. But I've got 2 machines. Let's use them, right? So I'm going to say 55 is going to be associated with, okay, now this is where I'm holding the phone. Now, first off, it won't let me associate it with an instance anymore. Watch what happens. It says, oh, sorry, no. You've got multiple NICs attached to that instance. You can't do this anymore. You got to specify which interface you want this. Now, so I'll go, okay, well, let's assign this public IP address to the network interface, right? And there's my 4 network interfaces. I can just scroll through and see what IP address is on each. And you can immediately tell which ones are the statics and dynamics, right? Definitely dynamic, definitely dynamic, definitely static. Those are the ones, excuse me, we typed in. Now, why don't I just map them into the static IP address? I could, and I could demonstrate it, but we would take about 5 minutes to find out it doesn't work. Why? Because Ubuntu doesn't recognize that it has these interfaces. AWS says, oh yeah, you got them, but it's kind of like, you ever had an Ubuntu machine or a Linux machine? It's like jamming a network card and booting it up and expecting it to just pop in there. Doesn't work. It's the same thing that we just did. So we actually have to map these things. We'll say, I'm going to map this to the dynamic one, which Amazon makes sure Ubuntu knows about that one because it's part of the base image that they spin up. So I'll hit yes, associate. And then this guy. Let's associate this guy. And we will say that will be with the network interface and 2.45. Again, dynamic one right there. Yep. Associating. I'm going to open a command prompt while that's all happening. And my security group allows ICMP. And it allows SSH, so I should be able to type in ping 54.165.98.55. Enter. Whoo! Ping 54.165.36.100. Woo! I don't know why I get so into this. All right, so I've got the pings going. We got the public IP addresses. What now? Okay, now we've got to get in and SSH into the device. So I'll go with my secure CRT. Yes, I paid for this, but I'm just going to delete these guys out of here. These are old ones. But you can do this with PuTTY, which is a free one. Just about every terminal program to do this. Let me squish this into the screen so I can see the public IPs. Okay, so I'm going to do a quick connect. Let's go to 54.165.98.55, and we'll go with the username because Amazon requires you to do this with their base image, Ubuntu, right? I'm going to use the public key, which I created from Amazon. I just downloaded it to my download folder here. I almost said bucket. I'm too into the S3 world, right? This is the public key and private key set that I created the VM with, so I'm going to authenticate with that. Save session connect. Yes. Accept and save. And I am in. Now, let me make this a little bit bigger. We get into the little bit of Ubuntu Linux side of things. Now, I know some of you guys out there are like, I'm Windows only, I will never touch Linux. This part is actually not for you. I mean, okay, maybe it's for you if you ever want to be Linux, but this is for the Linux lover at heart, which I would say there is by far more Linux instances running in the AWS world than there are Windows instances because of the place of AWS and all of its hosting wizardry, right? So I'm going to show you how to get these 2 network interfaces running inside of Ubuntu. Very similar process for any flavor of Linux you want to do. ifconfig, right? This will list the active IP addresses, if you type it right, on the box. And I can see ETH0 and loopback. ETH0 being the dynamic one that we created. So the problem is it doesn't even know there is an ETH1, even though I went into the EC2 instance and assigned it an Elastic Network Interface card. AWS tells me that it's there when I look at the stats on the instance. And I just want to verify that it is. I'm doing it because I want to make sure it's there. It tells me that it's there, but it's not actually showing up in my instance. Why not? Okay, well, first things first, if you do a cat, which is kind of just display the text file, /etc/network /interfaces. This is a very well-known configuration file for Linux that says here is how your interface is configured. What you'll find out is Amazon said, hey, we're going to spin up this little subfolder here and put config files in there that configures your interfaces. Okay, so I'm going to go, then let's do a quick ls, a listing of interfaces.d, this folder that they're pointing to, and it looks like they only have a configuration file for eth0 .config. Let's see what's in there. Cat, put that out. It says, this is the primary network interface, auto eth0, interface eth0, inet DHCP. What's this? This is how the interface is configured. As a matter of fact, normally these lines, this piece right here, is actually in this file, this interface text file, and that's how Ubuntu knows about it. So it looks like Amazon did a little like, hey, let's do something new, and they created this interfaces.d, so they have like sub-configuration files for each one of them. So how do you make this happen? I'm going to do a copy. So let's just go up here and do a quick cp, copy command. I'll do copy that to etc network interfaces.d eth1.cfg. So what I just, sudo, got to bust out a little admin permissions, and it's just given, it will give a lot of these errors just because it's trying to dynamically throw in an interface on the fly. It's not happening because it's the same IP address and all that kind of stuff, right? So I'm going to do a, let's just go back up and do that list command again. Now I've got two of those files. That's good. So I've got to edit this file. Now I know some of you are like, dude, you're like a Linux whiz. Actually, no. I just kind of play this on TV. I'm not a super Linux guy. I totally want to be a Linux ninja, and I've been practicing for probably about a year on Linux, but I would definitely not categorize myself in. I mean, just the fact, if you're a true Linux person, you're like, I can't believe you just used Pico. I spit on you, Jeremy, because real Linux people use VI as an editor because it's more universal and because you feel cooler when you hit control characters for everything. But I'm gonna do Pico because it's easy. I'm gonna do no. This is the secondary interface, and that's a little comment up there just so I can see it, and I'm going to say ETH1 DHCP. Now you might say, well, I thought this was a static IP address. Can you put a static in there? Yeah, you can. See, I told you I'm not a Linux ninja. I forgot to edit that with admin permission, so I can't save it. So hang on. There we go. Changed it all up. Control X, yes, save the buffer. ETH1 config. Now I'm looking good. We've got ETH0, ETH1. Now we got to bring up the interface. So I'm going to do a sudo, remember this time, if up ETH1, which triggers Ubuntu to say, okay, let's check my config files and bring that interface up. Looks good. So I've got this interface now. Let me just do ifconfig. Woo! We've got ETH0 right here, the dynamic one, and ETH1, that's our elastic network interface. And check it out, even though it's DHCP, that's what I was trying to say, we don't have to put static in there because Amazon and all their wizardry says we will have a DHCP reservation, assign that interface every single time the IP address that you've specified. Good? So, looks good, right? Wrong. Because the problem is Ubuntu, let me just do, what's the command? Route -v. Yeah. So if I look at my routing table for Ubuntu, it says I've got the default route going to this, which actually, so it's saying I'm sending everything out ETH0. Now here's the problem. I can go in there and try and change it around, and I already have before, and you lock yourself out, right? You can't get back in. It's like it's one of those things you're like, man, if I just had the machine sitting right here, I could totally, from the console, do this. Well, you don't get a console in AWS. You can't right-click on the machine and say, view the console, because that's not what AWS does. You have to access it through SSH. So IP address changes get kind of tricky. So what I wanted to do was show you how to do this for you Ubuntu people out there. Why? Because I Googled it, and I saw there's like 500,000 other people out there that are like, dude, how do I put two interfaces and make them work in Ubuntu? I keep blowing up my instance. I'm like, I need to answer this question once and for all. So check it out. Here's what we do. Now I'm in the Ubuntu world. This is one method. You can use multiple methods of doing this. I'm going to use the one that I think is the best. I'm going to do a sudo IP route add default. So I'm adding a default route into this via 172.30.1.50 device ETH1 tab 2. Now, I know some of you are like, what? What did you just do? Well, I just added a second default route via the ENI, the elastic interface, and I'm making sure this is going to be out the ETH1, but this is actually going to be routing table, that's short for table, table number 2. I can actually go in there and do a IP route show table 2. And it says, well, table 2 is, here's the default. It's exactly what I just typed in there. So it's like this secondary table. Now you're like, why did you do that? Why didn't you just like remove this route and replace it with another one? I'm telling you, you'll break it because you're SSH'd in remotely. As soon as you remove the default route, you lose access to it and you're dead in the water, right? So we're creating a secondary routing table. Now I'm going to do a sudo IP rule. I'm going to add a rule to the routing table, and I'm going to say anything from 172.30.1.50/32, it's just the syntax of the command, needs to use routing table 2, and we'll just say priority 200. Now, what does that mean? I just added a routing rule to Ubuntu saying if anything comes or goes to that IP address, use routing table 2. Why? Well, think about it this way. We've got, I need to grab a whiteboard. There we go. Think about it this way. You've got a Ubuntu machine, right? And it's got exit points on here. ETH0 and ETH1. And you've got essentially all these different applications running on there. Web servers, stuff. I'm like, what else do you run on Linux? A web server. Other stuff, database services, all that kind of stuff that are like, how do I get out? How do I get out? Well, you can actually assign, you can either just let them use the default, and the default routing table says go that way, right? Or you can say, you know what, web server, Apache web server, I want you to go out ETH1. I want you to go out this IP address. And so what you're doing is essentially creating a specialized exit point for it. So you need to have a specialized routing table for that because you essentially have the system. So essentially think of it like the system default. For everything in the system that needs to get out, it's going to go out ETH0. You can change that, but that's not the way we're approaching it right now. We're saying that if anything comes or goes to that one interface, then use this custom routing table number 2 that we just created, right? Right. So we've now got routing table number 2 that's in play there. So I'm going to verify that rule by doing an IP rule show command and show me the rules. And I can see, you might say, well, what was this priority 200? What I'm saying is, in comparison to all the other tables, lower priority is better. So it's saying the only thing that beats it is a local lookup. Like if something's trying to reach the local interface, like it's right there, duh, it's rule number 0, essentially highest priority. That one always wins. But this one says, okay, if you're coming from, this is priority of 200, if you're coming from or to this, then use routing table number 2. Everything else, just use the main routing table or the default routing table of the system, which is this one that I showed you right here, route-v. This says go ahead and go out the ETH0 interface, right? Last thing I'm going to do is just flush the routing table, sudo IP route flush cache. And now we're good. Now we've got the rules that have taken effect. We don't want any cached rules or previous ways to go. So what can I do now? Now I can shoot back over to EC2 and VPC, elastic IP addresses, and I can yank this one, or wait, this one, off of the dynamic, the 172.30.1.222, which is a valid one, but if I want it to be a true ENI that I can rip off and take somewhere else, then I want to go in there and associate that address, and I can do this on the fly, don't have to power down anything. Associate that address with, let's go for this guy. Now you have to check this box, allow an elastic IP address already associated to be reassociated. It's grayed out until you do. So I'll click that, yes, associate, and there we go. Now, my guess, it's probably a pretty good one, is that I have totally lost access now to my Ubuntu instance. Not yet, though. Hang on. There we go. Okay, it died. So it just took a sec for that to take effect, but essentially my session was just lost to Ubuntu. I'm hitting the enter key. I'm dead in the water because I was essentially natted through to this IP address, and now I just changed that. So let's test this. I'm going to disconnect. Hit OK. Please disconnect. There we go. And I'm just going to hit the enter key again and reconnect. Drum roll, please. Please. Hang on. Let's try the ping. Ping 54.165.98.55. Ah. Oh, what did I do wrong? Okay. Okay, hang on. Time to troubleshoot. First thing, let's get a continual ping going. Bring this in, just do a -T on that. And we are dead. There's no doubt about that. I will associate this address. Let's get this guy back to the original interface, because obviously something went wrong with our new little interface there. And I will hope, so we don't have to trash the instance, that it suddenly picks up and responds to this. So we'll actually be able to see with the ping how fast it does that. Meanwhile, let's brainstorm. So we created the second ENI. We saw that showing up there. We saw the routes entered. We did the rule going in. Okay, good. Whew. Let's see if we can get back in. File connect. My mind is going crazy. All right, so let's go over here. And do a ifconfig. Make sure I didn't lose the interface. Nope, it's still there. Let's do a show IP route. This just shows the default routes on there. So IP route show table 2. Oh! Oh! That was easy. Look at this. Default route via 172.31.50. That's itself. That doesn't work. Hang on, route -v. It should be. This should be the default route. Essentially, I pointed this server to itself for routing table number 2 as its default route. So it says if you don't know how to get somewhere, then ask yourself. Essentially. So let's fix that. Let's do a what would it be? Route. Let's see. IP route help. There we go. Hey, it can tell I'm looking for a bailout there. IP route. There we go. IP route delete. So let's do sudo IP route delete default via 172.30.1.50 itself device ETH1 table 2. So now I'll do a IP route show table 2. Nothing. Okay, good. So sudo IP route add default via 172.31.1 table 2. Show table 2. Good. Good. Well, while I'm here, I'm going to do a IP rule show and see the rule. Okay, the rule is still looking good. It's still saying everything from this IP address use routing table 2, essentially, which is good. And routing table 2 says your default route goes to the right default gateway. All right, let's see how this works. So we got the continual ping going again. Let's do some reassociation here. Go to the network interface. This guy. Good. Check. Associate. All right, so now we've got it pointed to the new IP address. We'll see where this guy. See where this guy dies. Enter. See how long it takes. An elastic. Oh, there we go. Dead. Elastic IP address assignment to take effect. So it's. I'm hoping these pings come back. Hey! Whoo! I knew that was going to happen. I knew that. Good. Hey, look at that. So now we are back in, and this time we're coming in on the right IP address because we reassociated. You saw it go down, it came back up. We reassociated that elastic IP address with the private address 172.30.1.50. So some bonus info for you in this VPC environment. Not only how to do the VPC side of things, and we truly got into the nitty-gritty, but how to get an Ubuntu or Linux-based instance working with multiple elastic IP addresses and ENIs. At this point, I would love for you to try this yourself. So what I did was create a list of objectives. I don't like doing steps because, click here, go here. It doesn't help you learn anything. Just objectives to kind of wrestle through yourself. Create a VPC, add multiple subnets, custom routing table, add a second internet gateway, launch a Windows or Linux instance. Obviously, I went on a great Ubuntu adventure in this nugget. You don't have to do that. If you're more familiar with Windows and comfortable there, go there. Assign the elastic IP. And also, can I mention, You won't see any of the Ubuntu stuff on a certification exam. It's more of like, did you get the concepts that all those things tied together? I just added in the Ubuntu stuff because it's just fun, it's real world, and it helps solidify some of those topics that we saw. Modify your security group, access it from the outside world, and then see if you can allow full access between your two subnets so your instances can access each other. I hope this has been informative for you, and I'd like to thank you for viewing.